the next images that are on the next shuttle flight. Thanks for being with us today.
Well, thank you.
We're at Building 4707 in the Rapid Prototyping Lab, and we're joined by one of the engineers here, Curtis Manning. Curtis, thanks for being here with us today. First of all, tell us a little bit more about what rapid prototyping is.
Well, rapid prototyping is a term used to describe the layer upon layer deposition of material to produce three-dimensional parts.
So you're essentially growing three-dimensional parts.
Growing parts.
How does this fit into the Marshall mission?
Well, the most important aspect is that we want to support in-space manufacturing. If we're traveling to the moon or to Mars, we need ways of actually producing parts on the go. And once we get there, we need ways to actually build habitats, if you would. So this process enables us to look at those long-term goals.
So you're trying to research a way to have one machine able to build multiple parts?
Yes, one machine using multiple different materials to get that end result.
Well, you've got a computer over here with a model on it to show how you build these parts. Can you explain it to us a little bit?
Yes. This actually shows what the machine sees in the layer upon layer deposition. And we're actually putting layer on layer and growing that part. So that is the process that we use in doing rapid prototyping.
And making a three-dimensional part.
Yes.
Well, let's start with this really large machine you've got over here. What's this one doing?
This is a selective laser centering machine, and it's actually centering powder to the layer beneath it. It has a binder in it, so once that laser hits it, it actually binds that powder in whatever geometry the CAD software is telling it to.
And you can make three-dimensional objects like this?
Exactly like this. Matter of fact, this is the part that we're growing in the chamber right now.
You're just putting the layer of powder over it, and then the laser will attach it to the solid layer below it.
That's
okay.
it.
Let's take a look at what you've got over on this side now. Now, this is the one that I found interesting. You're actually got, I guess, a spool of plastic material. Looks like fishing line almost.
Yes, this is an ABS plastic material, and it's in a spool form. But once it's fed into the head of this machine, it's heated at extreme temperatures and extruded, sort of like a hot glue gun.
And you can end up building complex things like this.
Yes, a complex just like a bone. And this is another application that we can use this process if we are in space to help us look at how we can remanufacture a human bone if necessary.
Now, you've got another machine over here building layer upon layer, as you said, but this one uses a liquid. What is this, a resin?
This is a photocurable resin that's cured with ultraviolet light. This is an example of the part that you can build in this resin. And again, it's liquid, so it sits in a vat. But as the light hits it, it cures it layer upon layer. It cures one layer to the other. And when we're done, we actually grow this part down in the liquid.
So the light can hit one side of it, skip over, and then cure the other side.
Exactly.
Solidify that and leave the inside liquid.
Exactly.
Interesting. Curtis, we've stepped across the lab now to a machine that looks like it has a giant spool of aluminum tape in it. What is this one?
This is the ultrasonic consolidation process, and it uses ultrasonic consolidation energy to bind two pieces of aluminum together.
So it makes a nice thick stack of aluminum.
Yes, it does.
And then it uses a traditional method to cut it out.
Right. It goes and grabs the tool that's needed and actually cuts out the geometry. And in this case, it's a gear.
So you're building a gear right now in this
Right
one.
now.
All right, let's take a look at this machine, which uses that same spool of plastic like we saw across the way, except this one's black. What is this one doing?
This machine is the latest and greatest version of the FDM process that we looked at earlier. It uses the same technology, but it uses a lot more materials, and it's a lot faster.
And in fact, you're building something for return to flight with this one, right?
Yes, this is an actual part that we built that allows us to look at the foam on the ice frost ramp. And it's a functional tool. That's the most important part. We're able to build functional tools with these processes.
And this is in use right now?
Right now.
And now this machine here, I guess in a way, could replace your traditional welders. Is that right?
Well, it's a way of looking at putting welding in a different light.
How's that?
The powders are actually sprayed into a focal point, and the laser meets that at that focal point and actually welds on the spot. So it's a way of doing, I guess you would call it spot welding. and it enables us to repair parts as well as add on features.
So it can be very fine welding, and it doesn't harm the original part either.
Exactly.
Now let's take a look at your latest and greatest machines. In fact, these just arrived here in rapid prototyping last week. What are these?
That's right. They're still on the pallets, matter of fact. This is the electron beam process, and it's very, very unique in that it uses an electron beam instead of a laser to melt the powder. But the one thing that is unique is that we can use exotic materials, exotic metals. This is titanium.
Oh, wow.
So we're able now to build titanium parts and pull them right off of the machine and use them.
And the future of prototyping right here in Marshall.
That's it.
Thanks a lot for having us today, Curtis.
Thanks for visiting.
Bill, it's amazing the way they can make those intricate parts with just plastic wire and dust.
It was fascinating to watch. Plus, we got to see some great new technology as well as some impressive shuttle video.
Many more capabilities here at the center. Join us next time as we focus on Marshall.